Don't be confused by the genes. I'm actually a Silicon Valley geek. I'm Neil. By day, I work for NVIDIA. By night, I run the Khronos group. I've been honored to serve as the president for a few years. And at the moment, we're going to be talking about standards, which is a Khronos thing. So I'm going to mainly have my Khronos hat on today. So to give you a bit of context, who is, or what is a Khronos? The Khronos Group is an open standards consortium. It's about 120 companies. It's been in operation for around 15 years. So everyone from Apple and Google and IBM and Intel, all the way down through to small startup companies. And we're one of many different standards organizations in the industry. We have a specific focus, and that is we concentrate on enabling application developers to access cool stuff in accelerated silicon. And today, kind of the cool stuff that you want to be accelerated are things like 3D graphics, vision processing, AI, and augmented reality, really, parallel computing in general. So why does AR in particular, I think, need some of these standard APIs? And AR is going to need hundreds, if not thousands, of standards to come together, because AR, the joy and the nightmare of AR, so many moving pieces have to come together for it all to work seamlessly. This is just one small part, but I think it is an important part, because without standard APIs that can be adopted across multiple AR platforms, it's going to present an enormous amount of fragmentation to application developers. If you have to rewrite or port your AR application to every single device, and there are dozens of devices coming, it's not going to be a real market for anyone. No one is going to make any money, and we're going to stall in the consumer's eyes. But just as importantly as that portability, it's power efficiency. If we can create effective APIs to let developers get to the cool acceleration capabilities of modern silicon, not only can it go faster, your AR be more reactive and interactive, it's going to consume less battery power, because specifically designed acceleration hardware has been designed to consume less battery as well as go faster. So for many reasons, we need to have this web of good, well-designed APIs. So what is Khronos working on? This is, I'm not going to have time to go through them all. You'll be glad to hear. But to give you kind of a flavor, we kind of can divide them up into kinds of categories. On the output side, we're probably best known historically for some of our 3D graphics APIs. OpenGL is a Khronos API, OpenGL ES, which is the mobile version we did for the mobile industry. We have the new generation 3D API called Vulkan, which is higher performance, lower latency, perfect for augmented and virtual reality. At the bottom there, we have like the general purpose compute APIs, OpenCL. If you have multiple CPUs, DSPs, GPUs, even blocks of hardware or FPGAs in your system, you can use OpenCL as a programming framework to access them all and bring them all into the service of your application. At the top, we have some of the web standards, because the web is going to be vital for many, if not most, AR experiences. I think WebGL brings the power of OpenGL into your web browser. GLTF is actually not an API. It's a file format for efficiently transmitting 3D assets. So if you have a wireless 3D headset, you want to have an amazing augmentation, you have to beam it down. So you want something that's efficient and compressed and streaming to enable a good experience. GLTF is that. And then on the left-hand side, the newest area, vision and AI processing. Let me just touch on that, because it is less familiar. So OpenVX, VX stands for vision acceleration. Unlike OpenCL, which is a very low-level API, you have control over everything in OpenCL. OpenVX is more like a Lego kit. So you have a set of blocks, which are the typical vision processing functions, and you connect them together in a graph. And it's up to the implementer, typically your silicon implementer who has an OpenVX implementation, will take your graph and run it the best way they know how on whatever processors or hardware they have available. And the latest extension to OpenVX is for neural networks, because lots, if not most, of traditional vision processing is now switching over to using neural network technology, particularly for pattern matching. And so now, with the latest extension, we can use the OpenVX graph to actually express a neural network with tense objects connecting the various layers. And then last but not least, we have the neural net exchange format, which is kind of like the 3D exchange format we were talking about earlier, but for trained neural net data. So you can use any number of training frameworks, export a NNEF file, and import it on your low-power inferencing engine. And OpenVX is going to be able to import NNEF files, so everything kind of hangs together. Then we have the newest initiative that is so new that we don't have a name for it yet, but it's particularly relevant to this community, so I wanted to spend 2 minutes on it, the Khronos VR Initiative, but I've realized from talking to people that it's AR2, XR, but it's been initiated by certainly the VR community. So we have all these different VR devices, the Rift, Oculus, the mobile, the Gear VR, the OS VR, which is the open source VR platform, Daydream, which is the Google VR platform. So at the moment, we're horribly fragmented. If you want to write an application, you have to port them across the different platforms. And typically, each of those platforms is supporting just one or two devices. So the idea of the VR initiative is to create two sets of APIs that surround a runtime, a developer, application developer-facing set of APIs. So an application can port to this one set of APIs, read the status of all the tracking and all the devices, and feed outputs down into a display or haptic devices. But also a device-facing, I should go down, device-facing set of APIs. So device manufacturers, perhaps an innovative new tracking device, not using gesture processing, whatever it is, can self-integrate into the stack, because we're finding that's the other bottleneck in the industry right now. There are more devices than the platform vendors have time to integrate. So this is a platform initiative that's just started. Literally, it started in October, so it's about 2 months old. But these are the companies that have already signed up for it, so it's a good quorum of the VR industry. And everything we're doing in terms of tracking and low latency display, suited for head-mounted displays, is perfectly relevant to the AR industry. So if this is of interest, please do get involved. Lastly, I mentioned that the web is important for AR at the beginning. I think this VR initiative is going to stand side by side with WebGL, which is the 3D graphics in the web browser, to really enable the work that the W3C is doing with WebVR. And WebVR currently is just driving all of the rendering through WebGL. But with the VR initiative, we can save WebVR from trying to solve the native fragmentation problem of hundreds of AR and VR devices. So this division of labor, Khronos kind of working at the silicon and the hardware level, and the W3C working at the web level. It worked well with WebGL, and hopefully that will continue well with WebVR. And with WebRTC, which is the best way currently in the web to get to your camera, I think WebVR could quite quickly change into Web AR, and that's something that we're definitely interested to help encourage. So that's it. That's a taste of what Khronos is doing. As I mentioned at the beginning, Khronos is open to any company who wants to join. We are, by definition, an open consortium. So if this is of interest to you, you'd like a voice and a vote in how any of these initiatives are evolving, please do get involved. Thanks very much.